All right, so we're now moving into the section on the anatomy and physiology of articulation. And this begins with a discussion of the source filter theory and bones of the face. So to begin with, we use the word articulation in a couple of different ways. We refer to the articulatory system, and this is basically our speech system of mobile and immobile articulators. These are the body parts that we move to produce different speech sounds. We also use the word articulation to refer to body parts coming together, like the articulation of two bones at a joint. So let's get into source filter theory. You produce a raw sound in your vocal tract that is the sound source. And then the filter is your vocal tract itself. So the sound is produced by the sound source somewhere in the vocal tract, and then that sound is shaped by the vocal tract into speech. So for instance, the S phoneme is impacted by the shape of our vocal tract, specifically by the oral cavity. So if I extend my oral cavity by rounding and extending my lips, it's going to make the S sound different than if I have my lips retracted. So that's the difference between those two sounds, and s. So in this example, the sound source is that point of turbulence between my tongue and the alveolar ridge. It's that point of constriction that is making that white noise. And that white noise is being shaped by the vocal tract. So in the context of consonant production, it is the constriction, the point of constriction in the vocal tract that is producing some white noise, some turbulence in the airstream that is either the primary sound source, as in a voiceless consonant like s, or it is a sound source that is added to phonation, as in voiced consonants like z. So when I produce the Z phoneme, I have two sound sources: the voice, the phonation at the vocal fold, and that point of friction between my tongue and the alveolar ridge. But primarily, when we think about source filter theory, we're, for the most part, thinking about vowel production. And your respiratory system provides the expiratory air that's going to drive the vocal folds, that's going to create phonation. So your respiratory system is the power source in the source filter theory. And then the air that is pushed between the vocal folds vibrates those vocal folds, creating a raw sound. And it's a raw buzzing sound at the level of the larynx. So if you took a microphone and you threaded it back into your pharynx and listened to the sound of phonation within your pharynx, it would just sound like a buzzing noise. Zzz, it would sound like that. It's only after that raw sound produced by the vocal folds comes up through the vocal tract and is filtered through the vocal tract that it comes to sound like a human voice. So during vowel production, your vocal folds is the sound source. Your vocal tract is the filter. And when we talk about the vocal tract, specifically what we're talking about is the oral cavity, your nasal cavity, and your pharynx or your pharyngeal cavity. And you can think of these three containers, nasal cavity, oral cavity, and pharyngeal cavity as being three different chambers through which the raw sound of your vocal folds resonates. So let's define resonation. Resonation is when you take a raw sound, you put it into a container, and that container is going to select out a certain frequency to project best out of that raw noise that you put in. And the frequency that the container selects is based on the volume and length of the container. So here I have a container. I'm going to take this raw noise that is the sound of air blowing over the lid, the mouth of the bottle, and that raw noise sounds like. So I'm going to take that raw noise, which is my sound source, and I'm going to apply it to this container, which is going to act as the filter. So what you hear is that particular frequency that, based on its volume and length, this container pulls out of that raw noise and projects. So it filters out all the other frequencies that it doesn't respond to. And it propagates, it projects that one frequency that it does respond to best. And that one frequency is called the resonant frequency. So the resonant frequency of this bottle is the pitch that you hear. So if resonant frequency, the frequency to which a container best resonates, is determined by the volume and length of a container, then I should be able to get another container and it should have a different resonant frequency. And it does. So what you hear is I have a larger container, therefore it is selecting out of that noise, that raw white noise, it's selecting a lower pitch to project. I have a much smaller container here. Volume is much less than this one. The length is much less. And so with a smaller container, I can expect it to resonate at a higher frequency. And that is what we hear. So now if we go back to this slide and take what we've just learned, and thinking about the vocal tract being a series of three different containers, three different bottles, if you will, you can understand how the vocal folds creating that raw sound source of phonation, which is just that buzzing. It's just like it's that white noise. But when filtered through the three containers of the vocal tract, it produces the much more pleasant melodic sound of the human voice, because the containers of our vocal tract are each selecting out frequencies to put forward, and they are filtering out other frequencies. And everyone's vocal tract is shaped differently. And that's why all our voices sound differently. So we produce changes in our speech by changing the volume and length and configuration of the vocal tract. So think about, here we have the velum. The velum can rise up and seal off the nasal cavity. And that can affect the sound of your speech. That affects your resonance, right? I've sealed off an entire cavity of my vocal tract. that produces what we call hyponasality. I can move my posterior pharyngeal wall as well, and that changes the sound of my voice. I can change the volume of the oral cavity by pulling up my cheeks, and that changes the resonance. That changes the resonance of my voice, the sound of my voice. So we produce our phonemes, we produce articulation by changing the configuration of our vocal tract. In particular, we produce vowels by changing the position of our tongue. And when we change the position of our tongue, that changes the resonance of the oral cavity. So some examples are the vowel E. And so if you make the vowel E, you can feel your tongue is bunched up at the front of your mouth. But if you make the vowel all, then suddenly you're going to feel your jaw drop. You're going to feel your jaw drop a little bit, and your tongue is going to come way back down in your oral cavity. It's going to increase the volume of your oral cavity. All, oi. So by moving our tongue within our oral cavity, we change the shape of our oral cavity. And by changing the shape of the oral cavity, we change the resonant frequency of the oral cavity, which changes the vowels that we're making. That's how you produce different vowels